Hello and welcome to Maths with Jacob. This lesson will focus on problem solving. Try a simpler version. It is sometimes helpful to create a simpler version of a given problem. This may help you to work out the steps needed to solve the more difficult problem. Example 1. A swimming relay race consists of only 2 teams. Each team has 4 swimmers, making a total of 8 swimmers. After the race, each swimmer shook hands with every other swimmer. What was the total number of handshakes? Now here's a perfect example of starting with a simpler example and working our way through. So here's the solution. Start with 2 people and keep increasing the number by 1 until a pattern emerges. If you have 2 people, that's all. Let's say they're swimming against one another. At the end, there's only 1 handshake. That's it, because there are only 2 people. If there are 3 people, okay, this is how we do it. Pretend the swimmers are A, B, C, and down here A, B, C. So we draw this table, and we have this vertical section here, and the horizontal section, and we put the names of the swimmers on each. In the cells here we fill in AA, BA and CA, because when you go across and up, that's AA. You go across and up, BA. You go across and up, CA. So this represents 2 people. That's all that represents. We do the same here. AB, BB and CB, AC, BC and CC. Remember, there are only 3 people, A, B and C. And these represent the 2 people who shook hands. Now we're going to cross some of these off because let's have a look. We don't count the 1 person because 1 person does not shake hands with himself or herself. So we cross those off. That's what that means. That's why I've got that in yellow. That does not count. Over here, if B shakes hands with A, that's exactly the same as A shaking hands with B. So we cross that off. C shaking hands with A is the same as A shaking hands with C. So we cross that off. And the same here. CB is the same as BC. We cross that off. In other words, the ones we are interested in are the green colours. So there are 3 handshakes when there are 3 people. When there are 4 people, you do exactly the same thing. You get rid of those because that's only 1 person. And we don't count 1 person shaking hands with himself or herself. That just doesn't work. BA is the same as AB. So we keep crossing these off because they are the same as these green ones. So they go. So the only ones we're interested in are the green ones. And look, 1, 2, 3, 4, 5, 6. 6 handshakes. 2 people, 1 handshake. 3 people, 3 handshakes. 4 people, 6 handshakes. Let's look at 5 people. A, B, C, D, E, A, B, C, D, E. Get rid of those for obvious reasons. And get rid of all of these because they are just the doubling up of the green ones. So they all go, because they're the same as the green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 5 people, we have 10 handshakes. So let's have a look at the pattern on the next slide. If we summarise the information on the previous slide, we have 2 people, 1 handshake. 3 people, 3 handshakes. 4 people, 6 handshakes. 5 people, 10 handshakes. Look at the pattern. From here to here, that increases by 2, because 1 plus 2 is 3. From here to here, it increases by 3, because 3 plus 3 is 6. From here to here, it increases by 4, because 6 plus 4 is 10. So from here to here, it must increase by 5. 10 plus 5 is 15. From here to here, it increases by 6. 15 plus 6 is 21. And from here to here, it increases by 7, and 21 plus 7 is 28. The pattern we picked up is that it increases as we go across. It increases by 2, then it increases by 3, then it increases by 4, so then it increases by 5, 6 and 7. And that's how we find the pattern. Example 2. A family went to dinner and the total cost was $40. They want to give a tip of 15% to the waiter. How much is the tip? Solution. The easy way to do this problem is to find 10% of $40 first, then use this answer to help you find 15%. So 10% of $40 is $4. That's pretty easy. Finding 10% is easy. We know that 10%, or 1/10 of 40, is 4. 4 tenths are 40. So 5% must be half that amount. If 10% is 4, then 5% must be 2. So 15% of $40, because you got 10% plus 5%, that's your 15%, is $4 plus $2, and that's $6. Example 3. There are 16 players who enter a knockout singles competition in tennis. How many games need to be played to determine the overall winner? Okay, let's do a simpler version. If you have 2 players, you only need 1 game. So let's keep that in mind. 2 players, 1 game. If you have 4 players, I'll put the draw down here. The players are A, B, C and D. They are the players. Remember, there are 4 of them. There's the first game between A and B. There's the second game between C and D. These are the 2 winners of the first 2 games. So that must be the third game to get the winner. So you have 3 games. So for 4 players, you have 3 games. Let's see what happens when you have 8 players. Here are the 8 players. P, Q, R, S, T, U, V, W. Let's circle the games. 1, 2, 3, 4. That's the first round. In the second round, 5, 6, and in the final, 7. In other words, if you have 8 players, you play 7 games. Now, have you noticed a pattern? Look at the pattern. 2 players, 1 game. 4 players, 3 games. 8 players, 7 games. So the number of games is 1 less than the number of players. I'll repeat that. The number of games is 1 less than the number of players. If you have 16 players, we take 1 less, and that gives us 15 games to determine the winner. So there are some great examples there of solving a problem by looking at a simpler version. Hello, mate.